Hello, good day, good day, good day. Okay, now some of you said I should make some small video on binary operations. So I'm going to, you said you want identity element in the inverse, so I'm going to brush through the identity element in the inverse. So look at it very well. Later on, I will start from the beginning, then I'll make videos on all here. So at this point, I'm going to focus on the identity element and then the rest, yes. And then as time goes on, I will do the rest. Now let me talk about binary operation. Binary operation, binary means two, and then binary, you see, when it comes to indices or number bases, binary means two, which comprises of zeros and ones. Yes. Now it's comprised of only zeros and ones. Yeah. Now at this point, I want to talk about the binary operation. Now binary operation also means that it's a situation where we combine two numbers with a particular operation. I will not say addition, I will not say subtraction or multiplication. This one we're talking about binary operation. Binary operation, we have some symbols that we use when it comes to binary operation. I will do the introduction in one of the videos here, but this one I'm going to do it identity elements, so I will not do a lot of explanation on the main concept behind the binary operation, yes. But the thing is that combine two elements, two numbers or two elements to get a number. Yes. Now, so some of the operations include a lot of things. I'll talk about it. Yes. Now, what I want to talk about is the identity element. Identity element. Now, identity element is the same as neutral element. Neutral element. So either the identity element or neutral element. Now, since our mathematics is concerned, identity element to use letter E to represent identity element. We use the letter E to represent identity element. The letter E to represent identity element. So I'm going to draw the identity element. Now, let's move on to another identity or mathematical operation. Now, in mathematical operation, we have multiplication, addition, subtraction, and division. Now, when it comes to get an identity, we have identity for multiplication and identity for addition. Yes. Now, so let me talk about this. Now, if I'm talking about identity, then you have to go back to multiplication. When I multiply 4 by a particular number, I'm going to get 4 itself. What number is that? 1, right? Or 1 times 4, I'm still going to get 4. We call the 1 as an identity. So identity means 1 for multiplication. So when we perform any number times the identity element, I'm going to get that particular number. Or the identity element times any number, I'm going to get that same number. That's a concept you're supposed to know about identity element. So identity multiplication is 1, because any number will multiply any number by 1 or 1 by any number, we get that particular number. And that is what we call the identity element. Now, this is for multiplication. I will talk about identity element for addition. Now, we have a certain number. When we add another number to it, we get the same number. What number is that? So 4 plus any number, that was going to give me the same number. The number will go as 0. 2 plus any number, that will give me 2. It is 0. So 0 is the identity for addition. 0 is the identity for addition. So therefore, we know when it comes to addition and multiplication, it's also commutative. So either 4 plus 0 or 0 plus 4, I'm still going to get the same thing as 4. And that is the concept you're supposed to get when we are talking about identity element. So when I come to identity element in binary operation, it means that I have to combine two elements with an operation. So let's say A operation, an element. Let's say E. I'm supposed to get E. I'm supposed to get A, where E is the identity element, just like A times 1 to give me A. I hope it is very simple, yes. But this one is not multiplication, so I will not say identity element is E. It can be anything, yes. Or if I say E operation A, I'm still going to get E. It is not only A. When I perform any operation on the identity element, I have to get that same element. And that's the concept you're supposed to get. identity for multiplication is 1, identity for addition is 0. Now, so when we come to binary operation, let me define the identity. I can define identity in two ways, either in the form of a set or in the form of real numbers. Now, let's consider a non-empty set. Now, if I say non-empty set, it means a set in which the numbers are not empty. This one is empty set. It means it has nothing in it. So non-empty set means that the set has an element. So let me consider non-empty set X. So it contains elements. Now when X is closed, so I'm considering a situation where S is closed, which means S is closed. It means that anything we're going to talk about it belongs to the X. So S is closed. Now, let me consider another element that belongs to the same set. So let's A and then E, which belongs to the same set X, which means A and E, but they are all a member of the set X. You understand? Yes. Whenever I perform operation on the two, and whenever I perform operation on the two, the operation I'm using here is asterisk. Whenever I perform operation on the two, I want to and I'm getting A or when I say E operation A and I'm still getting A, then what can we say about the E? It means that E is the identity what element. E is the what identity element. This one I can also combine it. Then E, if this one goes, then E is called the identity element. Identity element or neutral. Identity or neutral element. So it is as simple as that. So this statement is supposed to put. I can also combine them. Let me define this one in terms of real numbers. Now let's say let A be the identity element. Let A be the identity what? Element. Where A and E, I'm using just A and E, all of them belong to R. What is R? R is a real number. R is a real number. I'm defining. Now, if A operation E is giving me A, or E operation A is also giving me the same A, then it shows that the E is truly the identity element. Okay then. Then it shows that E is truly the identity element. So if this one goes, then it shows that the E is truly the identity element. So identity element is so simple. You can define it in terms of real numbers. You can define it in terms of sets. Yes. So when they ask you to find the identity element, you have to know that when you combine any two elements, either A operation E or E B operation A, we are supposed to get the A. Yes. Now let me check one question and let's see how we can get the answer. Now, a binary operation. Now, I want to use this operation, triangle. Is defined. Oh no, okay, let me. Okay, it is defined on a set X. Now the set S is A, B, C. As shown in the table below. So we have a table like this. The table contains A, B, C. The table is the set X. Now the operation is triangle. So I want to just fill it. Now let's say here is A, B, C, here is B, C, here is C, A, here is A, B. Determine the identity element. Determine the identity element. Now you see, since we have a set like this, one of these ones is supposed to be an identity element because we said that identity element cannot be any number different from this one. Identity element is supposed to belong to the set X. Yes. You can see that if you look at this one, you can see the S is closed. So identity element is supposed to belong to this particular set. So A, B, C, one of them will be the identity element. Yes. But what is the concept here? Solution. The concept here is that, let me start from here. The concept here is that anytime you perform an operation on identity element, you have to get a particular element. So if I have M operation, identity element, I'm supposed to get M. And that is how we can use to determine the identity elements here. When we have a set of number has a fixed identity element. So this one will have only one identity element. It can't have two identity elements. It will have a fixed identity element. So, for example, let's see how we can get the answer. Now it means I have to combine two of these operations. So let me combine A operation B. Now on the table, I'm going to take this one as my first number and this one as my second. So A operation B on the table here, A operation B is B. A operation B is giving me B. Now, with this A operation B giving me B, you have to be able to identify the identity elements from here. So when you have A operation B is giving me B, what is the identity element per our explanation? If I have M operation E, it's supposed to give me M, where E is the identity element. So if I have A operation B and it's giving me B, which one is the identity element? Yes, I want to see if you are following or not following. Very good, yes, the identity element is what? A. Because it's giving me B, the identity element is A. Just like 1 times 4 and it's giving me 4. Identity element is what? Yes. So per this one, from this one, the identity element is A. I can't use this one to determine the identity element is. I have to check the rest whether it is true that the identity element is A. So let me combine C and A, then I'll see either AC or CA, any of them. So let me say CA. So CA from the table, we have C operation A. C operation A will give me what? C. C operation A is giving me C from the table. Which one is the identity element? So C operation A giving me C, meaning the A is still the identity element. Understand? But I can't make a conclusion now. Let me combine B and C and see what is going to happen. B and C, either BC or AC, either BC or CB. So let me say BC. Now on the diagram, B operation C is giving me A. B operation C is giving me A. Now, per our definition for identity element, if B operation C is giving me A, what can you say about this? B and C, which one is the identity element? It is not giving me B, so C is not an identity element. It is not giving me C, meaning B is not an identity element, so which means B and C, none of it is an identity element. So with this one, by our two expression here, it shows that A is the identity element. So I will say that therefore A is the identity element. So this is as simple as that. Yes. Now this is one part. We can also talk about this one is for a set, a table. We can also talk about a situation where it is not a set. So let me talk about that one too. Let me talk about that one, then we see what to do. Now, an operation as terrace is defined on a set R of real numbers by some come to define it. So let's say A operation B is giving me A plus B minus 10. Is this place clear? A plus B minus 10. So let's say it's giving me A plus B minus 10. Here is A operation B is equal to A plus B minus 10. Yes. Now determine the identity element. Now, so this one is a real number. Let's see how we can find the identity element here. So the operation is A operation B is equals to A plus B minus 10. And we are supposed to find the identity element, right? Okay. What is the definition for identity element? Identity element says that A operation E or E operation A is supposed to give us A. So we can take this one or this one, any of them is supposed to give us an answer. An identity element is commutative. So let me consider A operation E. I can also use a different letter. It's supposed to give me A. You can also choose to use E operation A. It's supposed to give you A. Now at this point we have to compare. When you compare this one to the binary operation here, it means A is the same as A, B is the same as what? The same as E. A is the same as A, B is the same as E. So where I see A in this expression, I'm going to put A there. Where I see B in this expression, I'm going to put E there. So with this expression is the same as A plus B. The B is the same as E. So I have E minus what? Minus 10. And this one's supposed to be equal to A. So what I have to do here is to find the value of E. That is all. So I need to group like terms. So I have E is equal to what? A. Now this A will cross the equal to sign. So minus A. Then this 10 will cross. So plus what? Plus 10. E is equal to 10. A minus A will give us 0. So which means identity element is equal to 10. Identity element for this. Now let's move on to the next video and we solve more questions on it. Yes.